Hi, I'm Chris from Airwindows, and hey, you can do this. Because this is Airwindows Hypersoft, and this is my secret project for the last couple of weeks. So you can see it here. We've got an input, a depth, a bright, and an output. I will point out that there's no real level matching here, so you can't actually have it give a consistent level for pretty much any kind of input. No matter what you put into it, the output level is going to be different in some way. So we can turn it on, and a whole bunch of extra energy is jumping out. That's because this is doing strange, weird things, which I'm going to explain with the use of visual aids, to take a soft saturation, which we're used to as the kind of thing where you don't just clip, instead you sort of progressively go into full clipping as you reach the maximum. This creates a curve where the sharpest part of the curve is not the maximum. And I'll show you what that does momentarily. But the first thing I'd like to do is take some of my little cards that I draw things on. These are the same cards that I'm doing the arrangement cards thing with. You can buy a box of these blank ones quite easily. And here's where we're going to start. This is a really badly drawn sine wave. This is what we're doing to start to explain what's going on in this process, because you can also do a hard clip. And you'll notice that with a hard clip, the sine wave goes up to the point where it clips, and then it just stops. What that does is it puts a sharp corner on the wave. In a frequency spectrum analyzer, what you see is a stack of harmonics that get added, that extend way out, because the sharpness of the wave determines how high the harmonic is that you're creating. Normally, if you do a soft saturation, you're going to make a stack of harmonics much more slowly. If you're using, for instance, a sine function, which I do on plugins like Density, and a bunch of other stuff. I've had console versions that use that and the arcsine function to decode it. Those just sort of add the first harmonic that you're going to get to, and then just stops. And you have to overdrive it really, really hard to produce higher harmonics, and they'll show up one at a time. But what I'm looking to do is something more like this, where you've got a high harmonic, and it's not at the top of the wave. Instead, the way that it's arranged is causing the sharpest curve to happen somewhere other than at the top. I don't know if anybody's actually done this. Maybe they have. I don't know if anybody has pursued it in exactly the way that I have for the reasons I have pursued it. Because I have this hunch that's been reinforced by working with Airwindows Meter that good sound is having the distribution of peaks such as you get with soft clipping or hard clipping or whatever. If you're using Airwindows Meter and you hard clip, that makes the peaks just stop at a particular point. And if you soft clip, they will kind of smush up to that point, and it'll still be very concentrated in that region. I've recently done work with Air4, if I remember correctly, where I had a slew restrictor which did the same thing. It was able to make slews literally stop at a particular point, and it decided that was probably not good either. So I made Air4 to do similar stuff that I've done with a mastering prototype that I've built, which lets you do a sort of ratio control and spread out the region of clippedness to be a wider region if you want. And this is what I'm working on in Hypersoft, because soft clipping still smushes everything up into one particular fixed hard clip point. But what if you had it work kind of like this, where this is called extreme circle top, where you do the clipping, it cranks up like crazy for softer areas, and then there's this transition point where it transitions to what's actually a very smooth curve. Well, this turns out to be fairly difficult to produce, even if you're intending to produce exactly this. And there's another issue where if you produce high harmonics and they're not perfectly balanced, you zoom in on the middle of the wave as it's like seemingly vertical, but then you zoom in until it's a much more horizontal wave, and you might end up having those high harmonics producing this weird little discontinuity, which causes a bizarre kind of buzz. It sounds kind of like 60 cycle hum, but created by a fluorescent light. And this is clearly no good. You can't produce these in the middle of everything. So what I ended up doing was developing this funny series of wavefoldy behaviors. Literally everything is a kind of wavefold, meaning there is no point where it just stops and sits at clipping. Instead, the waveform that this algorithm produces is always going to become a wavefolder. And that has some interesting applications. For instance, this card I called Weird Wavefold. What I ended up coming up with is you can have it increase in volume until it's just about a straight line. But then as you get into the point where it is flat topping, it stays flat for quite a while. As you keep cranking it up and going into it, it makes this mellow curve rather than a sharp or increasing radius curve. The radius is not quite at the top, it's a little ways down. And then as you continue to push harder, it goes beyond the flat top, which again, it hangs on for quite a while and starts dipping back down again because it's a wavefolder. Like you can wavefold a sine wave. Some of my stuff already does that. Fracture, I think, does that. But in this case, it dips down into a sharp corner rather than just a normal wavefold, because it's this series of additional harmonics being added. And when you add the series of additional harmonics, you get weird results out of it, and this is kind of what it produces. I don't have a great way to demo sine waves, so what I'm going to do is just start playing this, and I'm going to turn the depth here all the way up because that is the maximum number of harmonics. And I'm actually going to turn bright all the way up, but I'll explain what that does in a moment. And output, I will pad just a tiny bit. With this, 0.5 works as effectively unity gain, except for the basic algorithm is not unity gain. And listen to this. We're going to crank this up until it is super distorted. Listen to the quality that it produces. Relatively normal. A little bit of dirt. And then we go on. So that doesn't sound like anybody else's clipper function, because it's not. It's this weird thing that I created. But wait, there's more. Because since this is doing a function where it is just applying a increasingly high-pitched series of wavefolders, like if you were running a sine wave into this, it simply increases the amplification. So it will produce a increasing series of pitches out of the wavefolders, but they are playing the role of harmonics. The way that that works, and this might actually do me a lot of good for building a 2-cassette plugin that has the proper sound of that, more than the 2-tape plugin that's the most recent one that I've done, which is really designed to be more along the lines of reel-to-reel, hi-fi, extremely high quality. But people don't want that out of a cassette, so this might be exactly the right thing. Here's the thing. If I am adding a sequence of wavefoldings at higher and higher harmonics, theoretically, I can check against, for instance, slew rate to see whether I have a high frequency that is loud enough and high-pitched enough to count as something that would produce aliasing. So it's just possible that this can be tailored to avoid aliasing at regular sample rates. Did I succeed in doing this? Nope. No, but it does a fun thing that you haven't seen yet, because I've showed you depth and bright at max. What depth does is it gives you a maximum number of harmonics you can add, and at cranking it all the way up, it's like 12 harmonics above what the normal one would be, so that's pushing things really hard. Bright sets the point at which it starts leaving that stuff off, like dialing it back if the underlying frequencies of the input stuff is too high in frequency and the slew rate is too high. So rather than being a slew clipper, this stops adding additional harmonics as the slew rate increases. And it does not exactly avoid aliasing, not even slightly, but it produces a sound that I think is kind of interesting. Listen to this. I'm going to crank it back up again, and then we're going to take it at full bright. Listen to, for instance, what the cymbals do. And I'm going to dial it back, and you're going to hear the highs sort of fall into place and be a little bit less aggressive, take on a different characteristic, because we're now taking all of the depth of this large number of harmonics that's being added and scaling it back, depending upon how bright stuff is. Goes like this. Bright, back up again. I'm pretty sure you, like me, heard the way that the super highs just jumped out when I cranked the bright. It was not a very obvious effect until I cranked it back up again. And then all of a sudden it's like, whoa, okay, those are unpleasant artifact sounding, aliasy sounding highs in there. That's the thing. It's all meant to sound basically good, but you should be able to tailor sort of the amount of high frequency sparkle coming out of this algorithm by setting how many of these overtones you want. And I don't think the number at full depth is necessarily the number you're always going to want. Because here's the thing. The way this works, at a really large depth value, what it's going to do is do its funny making the sharpest corner in the transfer function of the saturation wave be lower than full crank. It's going to continue to sharpen that. That means that bass frequencies and low mid-range frequencies and stuff like that is going to get additional chunkiness that you don't get out of simple soft clippers. Really seems to work that way. So if you turn the depth down, what you get is a more subtle sound. And I'm going to switch from this point, from the full band thing, over to a simple drum loop. And we're going to leave bright the way it is. And output might as well be 0.5 because the drum loop is not as dense in sound. This is starting off as a fairly plain room recording. And what we're going to do is start depth at 0 and then increasingly crank it up. and you'll presumably hear what that does. At depth of 0, this is not many layers of the additional wavefoldy things at higher and higher frequencies. But when I crank it up, it'll take on this interesting character, which is a little hard to describe, but I think I'm going to learn to like this on drum sounds. Go kind of like this. But then when I turn it on, and now I'm going to turn depth up. What do you think of that? As I turned depth up, the low frequencies and rumble and low mids of everything got kind of sharpened and focused. In fact, I think it was at its best around 0.5, to be perfectly honest. That's why that's its default. But here's what you can do with it, is you can make it do this, or you can have it be a softer effect. At 0.5, we have that additional tonal characteristic I was talking about. We can adjust bright, a little more hat, less hat, or less hat and more of that quality. Dial that back a little bit. I can make this out of a simple room mic. I think that kind of speaks for itself. So yeah, Hypersoft is this new plugin. I certainly expect to be able to use it in other things going forward, and I encourage you to play with it. Again, I don't know whether anybody else has done exactly this. I only know that this is what I was shooting for over the last couple of weeks of live streams and experiments. And I was looking to do something regarding soft clipping, except for the sharpest point of the clipping curve. Let me dig up my making the sharpest point of the curve not actually be at the top, so that the pattern of peaks that I create using this is more dispersed and less just like, okay, it's clipping, so the peaks only go up yay far and no farther. Because I decided that probably doesn't sound good. And this is basically where I've got to it. And one of the side effects is what's shown here, which is as you continue to distort into it, it hangs on to that flat top behavior as long as it can, and then goes into a full wavefold, but it's a weird wavefold where it sharpens up and then softens out again. If you run a sine wave into this, like I was doing a lot of running a 100 hertz sine wave into it and just ramping it up, having the sine wave increase in volume and listening to what the sounds were of the harmonics as they would get added. On something like Span, what you get is a series of harmonics, but way fewer of them than you'd get on a hard clip, but more of them than you'd get on a simple, for instance, sine-based soft clip, and then it resists adding any more. There's like yay many harmonics and then no more, and it just stops very abruptly. So this is the opposite of a really sharp hard clip. And I don't know whether anybody has done this, but I've done it now, so it's MIT licensed open source, and I'll be using it in further stuff going forwards. I hope you like it, and I'm continuing to work on Console X with the help of smarter people than me who know how to do things like make things compile properly and work on bugs. One friend of mine was going to look at some of my problems with the console X GUI demo crashing Reaper for me sometimes, and I'll see how that goes. I will continue to do my side of these things as hard as I can, because I make this stuff for everybody, no exceptions. And I hope you like Hypersoft. I'll talk to you later. Bye-bye.